Okay, let's look at this question 4. Ikhuluma nge-probability. Okay, so it's a two-part question. Scenario 4.1, it's on probability. It's on about our contingency tables. Then there's the 4.2, which is talking about what is this? A Venn diagram. Yes. So 4.1, we are given an experiment that consists of tossing a coin and rolling a dice at the same time. Okay, for the coin, there's two possibilities. It's either ilanda on a heads or tails. It's either ilanda on a kop or a tail. Okay. Then on the other side, you are also rolling a dice. A dice has how many faces? 6 faces. It's either now roll a dice value 1. Phinda roll futhi mhlambe kuvela u3. Kuvela ubani? U6 kanjalo kanjalo. Like a dice has 6 faces. So each face has a number to it. 1, 2, 3 all the way up to ubani? U6. Now this experiment, but we are tossing a coin and rolling a dice at the same time. Okay? So now roller it dice and a coin at the same time. It's either ilanda on a heads or a tail. 1, 2, 3, all the way up to bani u6. So let's take a typical example. Mhlambe sithi I coin ilende on a heads and then it dice lalenda on a 1, right? So uzoba nani? Uzoba ne possibility of, okay, let me not say possibility, but an outcome of heads and 1 on the dice. We are roller foot. Now roll the dice lakho uthola ukuthi ilenda on a 2. Flip a coin ilenda on a tail. Yabo ukuthi sona bani uthole I tailor no number bani no number 2. I'm just having this discussion so that uzo understand kahle when I write down a sample space for this experiment. 4.1.1. They want us to write the sample space. The sample space. So the sample space is represented by S. City equal to, say the curly parentheses or my curly brackets if you may. So ukhumbule urolla ini it dice flip in a coin. A coin ilenda either on a heads or tail. This is our coin. And then it dies. Okay, die. Die means 1 dice. I'm a dice. Okay. It die. Okay. It dies. It's a dice, right? It's a dice. The dice, it's plural form. Die means 1. Nangabe uti dice, upete more than 1. Ne? Upete more than 1. So the die, it's either ilenda on 1, 2, 3, 4, 5, 6, right? Or a 6. So now my nice sample space here. It's either ilenda on a heads, bese ikhombisa no 1 on a die, or ilenda on a head ikhombisa u2 dice, or ilenda on a head ikhombisa u3 dice, or ilenda on a head ikhombisa u4 dice, ilenda on a head ikhombisa u5, ilenda on a head ikhombisa ubani u6. Or there might be an outcome where it lands on a tail is khombisa u1. It lands on a tail is khombisa u2 dice. It lands on a 3, it lands on a tail is khombisa u3 dice. Then siba no T4, T5, T6. This is the sample space for this experiment. Okay. Bese on 4.1.2, but represent the results of the experiment in a two-way contingency table by using answer sheet number 1 attached. Okay, so I'm gonna take this from the question paper. I'm gonna put it here. 7 of 4.1.2. Besengsebenza ini black. So this is a two-way contingency table. Of course, there's another way I represent ngakhona, but I'm gonna show this one for this discussion. So for this column, for this block le, uzoba no H1. You just fill it in. You just fill it in. Lana kuba ubani H2, H3, H4, H5, H6. Come on. Easy 3 marks. Easy 3 marks. Then ubano T1, T2, T3, T4, T5, no T6. This is our contingency table. All right. Next question. They are asking us to calculate the probability of obtaining a tail and a prime number. A tail and a prime number. Okay, so sifuna ukuthi calculated the probability of obtaining a tail whenever you flip a coin, ne? And then at the same time and the number appearing on the die ibe a prime number. Okay, what are prime numbers? All right, this number lazy as bigger than 1, and the Leo number Leo a bigger than 1, it only has two factors, 1 in itself. I'm a prime numbers now. So on the dice we only have numbers 1 to 6. So sina 1, 2, 3, 4, 5, then 6. Then ubani ama prime numbers la. This is the first prime number 2, another prime number 3, another prime number 5. It's a number that you can divide by 1 and by itself only. So it's 2, 3, 5. 4 I'm consider as a prime number. Why? Because 4 you can divide by 1, yes. You can divide 4 by 4, yes. You can divide 4 as well as by 2. So 4 is not regarded as a prime number. Now, but is he calculated the probability of obtaining a tail whenever you flip a coin and getting a prime number at the same time when rolling it dice. So I'm gonna use a contingency table here to spot those outcomes. So bega only that the row lag no tail con. So T2 nyam include, T3 nyambala, T5 nyambala as well. Okay, nyambala as well. So for this, to answer this question, we're gonna say we must calculate the probability. Whenever we calculate the probability, so we want the probability of tail and prime number, and being a prime number, close bracket, equal to, whenever we calculate the probability, it's always the outcomes divided by the total number of outcomes. It's the outcomes divided by the total number of outcomes. So how many outcomes do we have? Umasifuna gutistole a tail and a prime number at the same time. So now 1, 2, 3. We only have 3 outcomes divided by the sample space or the total number of outcomes. The sample space, let's count up. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's divide by 12. So the answer is gonna be 1 over 4. 3 over 12, it's 1 over 4. Equal to, you know what, just also express it in decimal places. That's 0.25, ne? 0.25. Because memorandum they always write answers in decimal places. Just do it for the sake of doing it. Who knows? Maybe they mark the whole thing, and on the memo they don't mention they don't say leave it. I mean, if even on the question they don't even say leave your answer as a fraction or in decimal places. If they don't specify, just write it in fraction and then in decimal form as well, né? Okay, so that's 4.2, 4.1 for us. Now let's go and look into event diagram lapha ku 4.2. 4.2, during a birthday party, the main celebratant discovered that 61 of the invitees ate cake, while 41 ate a sandwich. It was also determined that 21 of the invitees ate both cake and a sandwich, while 7 refused to eat cake or a sandwich. Okay, laba bangadli cake nale sandwich, I don't know, maybe bayazitshela, or maybe they have allergies. I don't know. All right, so 4.2.1, they want us to plot or represent the given information on a Venn diagram. So a Venn diagram, we draw a rectangle to represent the sample space, right? And then we're gonna have ama events weight or ama outcomes weight as circles inside the rectangle and another circle. So sizoba nama mutually inclusive events. Mutually inclusive events. Why? Because of, we are told ukuthi some of the invitees ate both the cake and the sandwich. So lama events, they must intersect. So asithi cake, asithi lana yini is sandwich. Let me use a different color again. So now, how many ate both cake and the sandwich? Is 21, right? It's 21. Now, kwamele be careful again, man. You need to be very careful, very careful. Whenever you plot a event diagram, you always start in the middle. You always start at you always start in the middle, where there's an intersection. It's for 21, and then they come back and say, all right, 61 invitees ate cake. So abantu abayi 61 ate cake. 61 people ate cake. So the circle representing cake, there's a 61 inside that circle, right? But because of, out of that 61, 21 ate a sandwich and a cake at the same time. So total 61 sim subtract nobani nalo 21. 61, okay, 1 out. So that's gonna be 40. So that's gonna be 40. So lo 40 low simply means that there was only 40 people abadle ikeke kuphela. Laba abanye abayi 21, out of that 61, they also ate a sandwich. So nalaba abayi 40, laba abadle ikeke kuphela siyabafuna. So we need to calculate a value for this, which is 40 for only people for the people who only ate a cake. Then siyalapha kulo kanje ke siya ku sandwich, bangayika abantu abadle i sandwich nabaphelele. There's 41 people who ate a sandwich. There's 41 people who ate a sandwich, but out of the 41, 21 also ate cake. So 41 minus 21, sithola ubani u20. This 20 is for only the guys who ate what? A sandwich kuphela, right? So 20 plus 21 isinikeza lo ya 41. It represent abantu bonke abadle i sandwich. 40 plus 21, that's 61. It represent our 61, the invitees who ate i cake, ne? Abadle i cake. U40 ilaba abadle i cake kuphela. 20 laba abadle i sandwich only. Okay? And then we also have a value that is 7. That is 7. 7, there's another value that 7 refused to eat cake or sandwich. Ilaba abazitshelayo ke. Naba bayi 7. Abadlanga cake, abadlanga I sandwich. I think abajudge. Maybe they are allergic to lokudla lokho abaku-offerela iphathini. Who knows? So 4.2.2, how many invitees were at the party? So to calculate this one, we add wonke lama value. You add them up, wonke. So you do 40, 21, 20, 7 must calculate asithola what? Asithola what? Let me take out a calculator. So 40 plus 21 plus 20 plus 7 in total 88. So a total of 88 invitees were present at the party. Then siyaku 4.2.3, calculate the probability that an invitee chosen at random did not eat a sandwich. Did not eat a sandwich. Alright, so probability of not eat a sandwich, not eat sandwich, sandwich. Okay, sandwich. Bengifuna ukuthola spelling is correct. Alright, not eat sandwich. So bangaki. Alright, okay. This problem sizoyiphendula so. These are the guys who ate a sandwich. Yilaba bakule circle any highlighting green right now. These are the guys who ate the sandwich. Everything else or every other person outside this circle did not eat a sandwich. It's 40 plus 7. So 40 plus 7, that is 47. Ngoba calculate the probability, we're going to divide by the sample space, by the sample number, 88. So divide by 88, the total number of people in that sample space. So 47 over 88. So it's going to be 47 over 88 is equal to okay, I see it's a good decimal place. But it stays the same. About 0.53. Let me check. Yeah, 4. See, it's a good 3 decimal places. This is the answer again. Next question, 4.2.4. Calculate the probability that an invitee chosen at random ate only cake or only a sandwich. Alright? Bangayiki abantu abadle only i-cake? Naba. Abadle only i-sandwich? Naba la. Right? So the probability of only cake or only sandwich is equal to 40. Only cake plus, or simply means that we add, and then it's gonna be 20 divided by 88. Divided by 88. So sizoti 40, that's 60 divided by 88. So lana it's 60 divided by 88, and then we're gonna have 15 over 22. 15 over 22, and then CTSD 0.81. 0.681. It's 0.681. This is the answer for this problem. Okay, so last one. Are the events only cake and only sandwich mutually inclusive or mutually exclusive? Alright, the cake only and sandwich only, ngoba they are far apart. Maybe nangasebenzisa red just to highlight la. Nangu only cake. This is only cake. Blue, let me use blue to show only sandwich. This is only sandwich. So these are mutually exclusive. Ngoba the red and the blue don't intersect, right? They don't intersect. They are far. They don't touch each other. Umunyule. So it means what? They are mutually exclusive. They are mutually exclusive. They are mutually exclusive because they don't intersect. Okay, so this concludes the question 482 for this question paper. check out the description box. There's gonna be ama links for questions for this question paper. So for now, I'm saying signing out. Ungakhohlwa ukulike, ukushare, nokusubscribe. So for now, peace.